Hey class, this is our first video lecture on solving matrices, especially in systems. Objectives are, can we perform the matrix operations using a graphing calculator? That's the key. We talked about determinant inverses already today in class, and most importantly, can we solve a system of equations using the graphing calculator, using inverses, determinants, and matrices. Okay, so what we have here, it's a little algebraic reason why these work. What we have is matrix A. And then we have followed by matrix B. If we were to multiply these two matrices together, they're going to basically equal 1, which we call the identity matrix I. Notice once again, we know this because it has the diagonal i's in here, the diagonal 1's, I'm sorry. And it's basically the equivalent of reciprocals, or the equivalent of 1. The algebra equivalent is simply this. Let's say we have simply the variable x. If we multiply that by 1 divided by x, or the fraction 1 over x, that will basically equal x over x, which inherently is equal to 1. Basically nothing as far as multiplication goes. Matrices does not understand division, but it does understand multiplication. That's why we're able to multiply an x times another element to then cancel and get 1. We use this principle in solving matrices. So what we have here is matrix A and matrix B are basically inverses of one another. Instead of saying B, this is really A inverse. And we talked about that earlier in today's class. So if you take the matrix times the inverse, you will equal the identity matrix of 1. The same thing happens. If I reverse them and just switch the order and put B first, followed by A, and then multiply, you will also get the identity matrix. Okay? So again, it's the same as saying 1 over x times now x is equal to 1 as well. Okay? This is the only time where order can go both left to right and right to left. Okay? So that's the one thing we have to do. But the important thing is here is that matrix A and matrix B, when they do equal I, then they are inverses of one another and they cancel each other out. So we're going to use that now in the next slide. So let's talk a little bit about algebra. Since in matrices it does not understand division, let's say we had a problem like this. 2x is equal to 4. Typically we would do this. We would just divide by 2, both sides, x equals 2, and we now have solved for the unknown. But matrices does not allow us to divide. So how else can we solve this problem? Well, what we do is we start with 2x again. 2x equal to 4. And instead of dividing by 2, we simply multiply, use a different color here to show it, by 1/2. So we're now multiplying by a number. So multiply both sides by 1/2. So then here, the 2's cancel. X is equal to 4 divided by 2, which is just simply 2. So we would get the same result by using multiplication. Now, the only thing that's different about matrices is order does matter. So instead of putting the 1/2 here, what I'm going to do is put the 1/2 first, then followed by the 4. And again, we get the exact same answer. So this is the principle that we're going to use in order solving matrices. So here's how the matrix works. Let's say we have matrix A, which is a set of data we already know. Then we have matrix X, which we have no clue what it is. That's the unknown matrix. So your X, Y, Z, whatever the case is. Then we have matrix B. Again, another set of data which we know. Our goal is to solve for X. So how do we use it using matrices? Well, if we multiply matrix A by the inverse of A, we know that those two will then yield a product of the identity matrix I, which we learned to be 1. So then 1 times x will inherently equal x all by itself. Obviously, if we multiply the left-hand side by the inverse of A, we must do so on the left side. And notice I put it in front of B because the left side was left to right, so the right side has to be left to right. So then x is equal to A inverse times B. Since the identity times x just equals x, our final answer will be A inverse of B. So in order to solve for the matrix X right here, to isolate it, we simply take the inverse of A multiply it by b, and this will always yield the result for the unknown x. Very basic algebra problem, and that's the formula we're going to use to solve all matrices. So let's move on to a matrix problem and show how this works. So here we have a matrix, and again, let's identify the elements. This is matrix A. This is the unknown matrix X. So again, this is like, per se, a 2 by 2 matrix, and we want to figure out what are the missing numbers that go in there. So if then A times X equals B. So how do we solve for this? So once again, instead of going through all the matrix steps, we're going to say, all right, let's just multiply the first part by the inverse of A, the second part by the inverse of A. Those cancel each other out, and X, this matrix, is equal to whatever the inverse of A is times B. And again, today in our class, we learned how to use our calculator to figure out the inverse of A. So basically, I'm now going to pull up my calculator and see if I can turn it on here. And we're going to enter the data and plug it into the calculator. So what I'm going to do here is, again, go second matrix, and I'm going to type in the data for A. So I'm going to go over to edit, and I'm going to enter, and I want a 2 by 2, and I'll enter 11, 5, 2, and 1. I'll do it again for matrix B. Go to edit, down to B, make it a 2 by 2 once again. Enter in my data. Oops, -1 instead. Oh, let's do that again. I messed up. So down to matrix B, a 2 by 2. So 4, and then we're going to do -1. I typed in subtraction 1. You have to type in negative, so that's why I messed up. And I'm going to type in 2 here, and then 0. So now I have stored in my matrix A and B. So instead of going through all the stuff by hand, I can now tell the calculator I want to take the inverse of 1, or the inverse of A, and multiply inside B. So just tell the calculator that. So go to second matrix, pull up A, take the inverse, and then multiply it by matrix B right here. So notice on the calculator screen equals what we have written here in algebra. Hit enter, and there is the solution to the matrix. So now we know that matrix X, okay, is equal to, let me pull it back up here, -6, -1, 14, 2. -6, -1, 14, 2. I believe I got the right numbers there. Okay? And that is our answer. So this is matrix X, and we now solve for that. Let's show how we could use it in a system. So here we have a system of equations. And again, how do we write this as a matrix? Well, again, I'm going to start by identifying matrix A. And this is going to, again, my variables on top, my equations on the side. So the first equations for variables x and y are 5 and then -2. So here's my x and here's my y. The second equation, my variables are 4 and then -1. Notice the coefficient of 4 for x and -1 for y. So my variables are on top, my equations are on the side. If I multiply that by the matrix x, then y, notice the variables are on the side this time, and then the solution is my column heading. And the idea is that we want these variables to cancel out, and we're left with equation by solution, and that will equal our answer over here. So then our solution answers are equation over here, solution over here, and these numbers are the ones that go over there, 4 and 5. So this is basically saying, if we take this matrix and multiply it by this matrix, it will equal those numbers. Well, we have, again, AXB here. So if I scroll down a little bit, this is matrix A, this is matrix X, and this is matrix B. And we just showed that X is equal to inverse of A times B. So we can simply just type this into our calculator. So I'm going to scroll down, and type this in. So I'm basically going to enter these elements into my calculator as matrices. So again, I'm going to go back to my calculator. I'm going to re-enter my data as A. And again, I have a 2 by 2, so those look good. I'm going to type in 5, and then -2, 4, and -1. I'm going to do the same for matrix B. Whoops, over one more. And I'm going to type in 4 and 5. So this is going to be a 2 by 1, and 4, and then matrix, whoops, go back up 1, 4, and then 5. So once again, now a good way to pull this up, since I pulled this up equation last time, I can simply hit second, answer. Okay, and that pulls up the answer. And if I hit second entry, it pulls up the one before, and I can simply perform the same operations. So basically, it's now going to pull the same operations, and I hit enter, and there's my answers, 2 and 3. So my matrix is 2, then 3. So 2, then 3, and from here, we can see that x was on top and y is in the bottom. So our solution is x comma y, in our case, 2 comma 3. So notice we're able to solve the system not by using substitution or elimination and going through all the algebra, but simply by setting up a matrix, going through AXB, and get the same answer. The nice thing about this is, yes, it works for this, and you say, well, I could do this by hand, this is quick. But when you get to problems that perhaps are more lengthy, like application, or a 3 by 3, which we know take a lot of time, it's just as easy, just a little bit more data. So for homework, what I want you to do is, this is question number 1 from your homework assignment in class. You had you write the system here algebraically and solve it. I want you now to write a matrix setup for the same question, solve it using your calculator, and see if you get the same answer as you did algebraically. Okay? This question here we will do in class tomorrow at the beginning, showing how we do a 3 by 3. If you want to go ahead and try it, sounds great. And then we'll talk about this question here as well, where we have a little bit more algebra in here, but how do we solve it the same way? Okay? So that's really it for the first lesson. Again, take a look at this, try it out, and again, try the blue slide, question number 1, and we'll go over it rest in class. Sounds good, and we'll see you tomorrow.